Welcome. This week we're going to talk about decisions. Decisions are covered in Chapter 5 of your textbook, Big Java. What we want to do in this mini lesson is to learn how to represent one of the three basic control structures, the selection statement. In all of computer science, we only have really three control structures. The first one is sequence. In other words, we can execute our statements one at a time, one after another. The second is selection. This is also going to be referred to as decisions in this chapter. Selections allows us, the selection control structure allows us to execute statements depending on whether something's true or not. So we can conditionally execute statements. And then the third, we'll talk about next week, that's going to be iteration. That's loops. So for today, all we want to do is learn how to use a simple if test, an if statement, a simple if-then-else statement. We want to be able to implement them. When they say implement, they really mean code. So we want to learn how to write the Java code to execute a statement, any statement we choose, conditionally, depending on the outcome of that statement. And lastly, we want to understand how to group simple statements into blocks so that we can execute large chunks of code or several statements together as a single statement. And we'll see why that's important in a minute. Okay, here's a simple if statement. We're trying to withdraw money from a bank account, and you're writing the code for the withdrawal method. And you want to make sure that you only deduct that amount if they have enough money. We don't want to put an individual into a negative balance situation. So, on the left-hand side is the code. We're going to say if the amount of money to withdraw is less than or equal to the balance, compute on the right-hand side of the assignment statement, compute the new balance, taking the old balance minus the amount, and then assigning that value to the instance variable called balance. And at the end of that simple statement, there'll be a semicolon. We can see that pictorially in a flow chart on the right-hand side of the slides. The diamond in the flow chart is how you represent a condition. A condition is something that can either be true or false. There's no other values that it can be. So, a computer will test, is the amount less than or equal to the balance? If it's true, it will execute the body of the if test, namely balance is equal to balance minus amount. If it's false, it's going to execute the false leg. The false in an if test merely skips over the body of the if test and proceeds at the next statement. So the default is sequencing. So we're going to go to the line of code after the body whether or not the statement is true or not. Okay, let's look at the cousin of the if test called the if-then-else or the if-else statement. Here we want to have two paths. One if the statement is true and a different path if the statement is false. In our bank account withdrawal, we want to do different things depending on whether or not they have enough money in their bank account to cover the withdrawal. So we do our test if, and our condition is always inside of a left and right parentheses. So inside the parentheses, the test compares the amount to withdraw with the balance. If the amount is less than or equal to the balance, we will compute the balance by subtracting the amount they want to withdraw. Else, namely if the condition is false, we are going to give them a big fat overdrawn penalty. We're going to deduct that penalty from the balance and then assign that new value back into the balance. You can look at the flow chart. The difference between the two, let's go back to the first one. In the simple if test, there is no code to execute for false, but there is for true. In the if-else statement, we have code to execute a single statement whether it's true or not. It's really fairly straightforward. And here's what our pseudocode, things that sort of look like code. We have the if condition, the condition's in a parentheses, execute a statement, or if the condition is true, execute one statement, else execute two statements. We have a slight problem in that oftentimes we want to execute more than one statement if it's true, and perhaps more than one statement if it's false. So what we're going to do here is, if we have to execute more than one statement where only one statement is required or allowed, namely in an if test, we're going to go into the bottom of the slide. We're going to use a block statement. A block statement is nothing more than one or more statements enclosed in the block curly braces, left curly brace and right curly brace. So we execute the we include a left curly brace, then as many statements as we choose, followed by the right curly brace. That allows whatever's inside that block statement, no matter how many statements there are, to act as a single statement as far as the if or if-else statement is. And in fact, that block statement could even include other if tests in it later, inside of it. We'll see later on that this is going to create a little bit of complexity. We had our simple statement, our compound statement, and then next week we're going to have another type of compound statement, namely our loops. Here's what the syntax of the block statement is. Begin curly brace followed by one or more statements, followed by closing curly brace. Notice it's a good idea to line up the curly braces, and we'll see how to do this automatically using Eclipse. The compiler really doesn't care if they're lined up, but it's good coding practice to line them up either one on top of the other. And there's another style that formats it slightly different, but you always want to be consistent with your indentation. So here's an example of a block statement. We have two simple statements enclosed inside of curly braces. What's the purpose? We want to be able to group as many statements as we need together to form a single statement. Here's what Horstman's asking: why didn't we use amount less than balance versus amount less than or equal? And he's really just raising a business issue here, not necessarily a Java. If the withdrawal amount equals the balance, the result should be the withdrawal should be able to be made, and then the resultant should be a zero balance and no penalty. Notice that you can test whether things are equal. One's larger than the other, one's smaller, or one's less than or equal. Here he asks the questions, what's logically wrong with the statement? Notice he used the word logically. Syntactically, there's nothing wrong with it. If some condition is true, execute a statement. But remember, the if test executes a single statement. In this case, the single statement would be new balance equals balance minus amount, and then logically that following statement logically has no indentation, and that's going to be executed whether or not the condition is true or not. Here, our intention, or the intention of the person writing this, intended for both of those statements to be executed together or not at all. The way we solve it is with brace, the block statement. So if you put braces around those two statements, we should be in good shape. Okay, how do we compare values in Java? We have relational operators to compare two things. For right now, let's just talk about comparing two numbers. We'll see later that there's some issues that may crop up with our comparisons. But we're going to have 6 relational operators in Java. The left column shows those relational operators and the equivalent math notation and the description. They're fairly straightforward and self-explanatory. Greater than or equal, that means if either one is true, then the condition is true. Less than or equal. The next one requires a little bit of discussion. The equal sign is different from the single equal sign. Remember, Our assignment statement is represented by a single equal sign. So if you want to say if A equals B, you will have to say if A equal B, not if A equal B. The compiler will get very confused and give you some error messages if you say if A single equal sign B. It will think you're trying to assign B to the variable name A. So, in order to distinguish assignment from testing for equality, always use equal. Again, shortly we'll see that there's a few caveats to that. And then finally, we have a not equal sign. Not equal, on the keyboard, that's a exclamation point followed by an equal sign. Again, no spaces, any of those multiple characters, make sure you have no spaces in between the two. I'll probably in the future pronounce that when I pronounce the exclamation sign as bang. That's also bang equal, or I could pronounce it as not equal. Remember, equal denotes equality, single equal denotes assignment. That's really pretty much it. We'll see there's a few complexities that come up, but basically we can use an if statement. If some condition is true, execute a statement. We use the block statement if we want to use more than one thing to execute if the condition is true. And the if-else. The if-else is nothing more than an if statement that has a block of code or a single statement, which could be a block of statements, to do the true part, or we'll call it the if part, or the else part. And finally, we talked about how do we group statements into blocks. Why do we do it? We do it so that we can use a block of statements with several statements inside as if it were a single statement as far as the if or if-else is concerned. Okay, let's try these out. Right now, I think we want to try to open up our Eclipse and try out a few simple exercises.